derivation of Planck's radiation law. On the basis of the assumption or the hypothesis of Planck's radiation law can be derived. Let n number of oscillators or Planck's oscillators are there in a black body, and E is the total energy. So there are two terms. One is the total number of oscillators is n, and total energy of the oscillators is E, right? So if I consider one black body and the number of the oscillators at the surface of the black body is n, and the total energy of this n number of oscillators is written by E or given by E. Now what will be the average energy? Average energy will be like that, E by n, simply total energy divided by the number of oscillators. That will give you the average energy per oscillator. Okay, this is the average energy possessed by any oscillator. Okay. Now consider there are n0 atoms, or not atoms, n0 oscillators which have energies 0. n1 oscillators which have energy ipsa, n2 oscillators which have energy 2 ipsa, n3 number of oscillators which have energy 3 ipsa, and like that there are nr number of oscillators which have energy r ipsa. And if I add this n0, n1, n2, n3 nr, that will give you the total number of oscillators. According to Planck's hypothesis, oscillators can have any energy from 0 to a very high number, infinite, any energy. So we have considered that there are n0 number of oscillators which have energy 0. There are n1 number of oscillators which have energy ipsa. There are n2 number of oscillators which have energy 2 ipsa, like that. So that the total energy, the total number of oscillators is given by n0 plus n1 plus n2 plus n3 that is equal to actually n. Okay. Now if we use Maxwell distribution formula, from Maxwell distribution, what we can write, we know that nr equal to n0 e to the power minus r ipsa by kt. This is Maxwell distribution. That means, what does that mean? That means if n1, this n1 is given by n0 into ipsa by kt. This is energy. R ipsa is the energy of the particle. So n2, what will be the n2? n0 e to the power 2 ipsa by kt, right? What will be n3? n3 will be n0 into e to the power minus 3 ipsa by kt, and so on and so on. So from the short discussion, what we can understand that this is a black body. The black body has n number of oscillators at its surface. The total energy of the oscillators is E. The average energy is given by E by n, ipsa dash equal to E by n. Now according to Planck's hypothesis, the oscillators can have any energy starting from 0. So we have considered that there are n0 number of atoms which have 0 energy. There are n1 number of atoms which have ipsa energy. There are n2 number of atoms or oscillators which have 2 ipsa energy. Actually, oscillators are the atoms or the molecules at the surface of the black body. Oscillators are nothing special, but the molecules and the atoms which are present at the surface of the black body, they will act as oscillators. Okay, so these oscillators can have this amount of energy, and if we add up n0 plus n1 plus n2, n3 and so on, then we'll get the total number of oscillators. Okay, and from Maxwell distribution we have written this thing. Okay, now if I use Maxwell distribution formula here, what we'll get? That means we know that n equal to n0 plus n1 plus n2 plus n3, so up to nr. We know that. Okay, so if we replace n0, n0 will not be replaced. If we replace n1 by this term, we can replace that. We can replace n2 by this term. We can replace n3 by this term, and so on up to nr. Now if I take common n0, what will get? 1 plus e to the power minus r ipsa by, this is 1. This is 1 ipsa by kt plus e to the power minus 2 ipsa by kt, then e to the power minus 3 ipsa by kt, and so on. So if I take e to the power minus ipsa by kt, x equal to, if I consider x equal to this thing, so what will I get? I get n equal to n0 1 plus x square plus x cube, and so on. And we know from our knowledge of series that this series 1 plus x square plus x cube plus x to the power 4, that will give you 1 by 1 minus x. If I expand 1 by 1 minus x, I will get this thing. Okay, so n equal to n0 into 1 by 1 minus x. And what is x? Simple. X is e to the power minus ipsa by kt. Sorry. So the expression of n ultimately is n0 into 1 by 1 minus e to the power minus ipsa by kt. What is n0? N0 is the oscillators at ground energy. Oscillators have zero energy, right? Oscillators have zero energy. Okay. And what is ipsa? Ipsa is the energy. Okay. What is ipsa? Ipsa is the energy of oscillators. Ipsa equal to h nu actually. Ipsa equal to h nu. Okay. Now, if I want to get the total energy, we know that n0 number of oscillators have zero energy, n1 number of oscillators have ipsa energy, okay, and n2 number of atom has 2 ipsa energy. Okay, very good, we know that. But what will be the total energy? E. We have written total energy as E. What will be the total energy? Total energy is very easy. It will be given as 0 into n0, 0 into n0, ipsa into n1 plus 2 ipsa into n2 plus, if there will be one n3 having energy 3 ipsa, then it will be 3 ipsa into n3. Remember that this n3 oscillators each will have energy 3 ipsa. This n2 oscillators each will have 2 ipsa energy. This n1 number of oscillators each and every one will have energy ipsa. Okay, so that will be the total energy, so on so on. Okay, now if that is the case, we can write again using the Maxwell equation. How? We can write this term is 0, then ipsa into n1. n1 is n0 e to the power minus ipsa by kt. We know that. Then this term 2 ipsa into e to the power minus 2 ipsa by kt. Then 3 ipsa, sorry, n0 will be there. 3 ipsa, n3. What will be the n3? We know. What will be the n3? n3 is n0 e to the power minus 3 ipsa by kt, and so on. Right? Now, if I take common, what will be the common? Yes, that will be ipsa n0 e to the power minus ipsa by kt. I can take common this whole term. Then this is 0. This will be 1. From here, what I can write? I can write 2 into e to the power minus ipsa by kt. And from here, what I can write? I can write 3 into e to the power minus 2 ipsa by kt, and so on. Okay. So, if I again consider x equal to e to the power minus ipsa by kt, what I can write? I can write this total energy term E equal to ipsa n0 e to the power minus ipsa by kt, then 1 plus 2 into x, then 3 into x square, and so on. And what is this? This is actually expansion of 1 by 1 minus xl whole square. So I can write total energy E equal to ipsa n0 e to the power minus ipsa by kt into 1 minus xl whole square. What is ipsa? Ipsa equal to, again I know, h nu. So up to this point we calculated total energy and we have calculated n. We have calculated E and we have calculated n. From next video we'll start from here. Okay.